we're looking at area between curves now, okay? So we've done this right here. This part we've done before, right? Area under a curve, right? This is, the middle one is area. Yours is not color-coded, I know that, but this one, the middle one, is area under F, right? From A to B. We've done that. We've had tests on that. We've had all kinds of stuff on that, right? What we're going to do today is not extend all the way down to the y-axis or to the x-axis. We're going to go between two functions. So we want to find area between two functions. The concept is not hard. The concept is not hard. So if you don't even think about the calculus right now. All right? So like I'll give you a problem you've done before, probably in elementary school or junior high. All right? So you have a rectangle, right? And then inside the rectangle, you have a half circle, let's say, right? And you're trying to find the area of this part here, right? You're trying to find the area of this part here, right? What do? You find the area of the whole, then you find the area of the piece, and then you subtract them, right? You guys have been doing that for a while. That's what we're doing today. That's what we're doing today. The only difference is we're not looking at rectangles. We're not looking at circles. We're looking at irregular shapes. So there is no formula for irregular shapes. So how do we do it? We use the functions. We use the functions. So we take the whole. This is the whole. We find the piece we don't want. This is the piece we don't want. The pink is what we don't want. We subtract them, and we get the piece in the middle. That's what we do, okay? So what's the integration way of doing that? Right here. We find the area from A to B. We subtract the two bounds. Or we subtract the two functions. And we find area under the curve, okay? So the concept is really easy, but just find the area of the whole, find the area of the piece you don't want, subtract them, okay? You can split this up into two pieces like they did here. You can split it up like that, or you can just do it together as one. Either one works, okay? So, how do we do it? Well, if f and g are continuous over an interval, right? And g is less than f, so g is smaller than f. What do I mean by smaller? Has lower y values, has smaller y values. For all x, then the area, we could use this. If g has bigger y values, then we would just switch them. We would switch places. Whichever one has bigger y values goes first. How do we know which one has bigger y values? Well, the top curve minus the bottom curve. Top curve is going to have bigger y values than the bottom curve. That's why it's on bottom, right? F has bigger y values from A to B, so it's the top. G has smaller y values from A to B, so that's why it's on the bottom. Okay? Couple things though. Couple things. Pictures are important, especially if they don't give you a picture, because if you don't have a picture of what you're doing, it makes it that much harder. Okay? So pictures are important. Sometimes they'll give you a picture, sometimes they won't. Drawing a picture, sketching a picture is going to help. Bounds. Sometimes they won't give you the bounds. Sometimes they won't give you the bounds. They'll always give you these guys. They'll always give you the two functions, always. But sometimes they won't give you the bounds. You got to find the bounds. Okay, like on the first one, they're not going to give us the bounds. Okay? And then find area. Okay? All right, so number one. Luckily, they gave us a picture here. They drew on a picture, so we see the area we need to find. So the green It's not, again, it's not green on my paper, on your paper, but it's got an R. It's called the region R. So we have to find, so it tells us R, let R be the region bounded by the functions f of x and g of x, as shown in the diagram below. Find the exact area of the region R. No calculator. We cannot use calculator on this one. When you see these questions on multiple choice, most of the time they'll be non-calculator. When you see them on free response, most of the time they will be calculator. So I gave you both. I put some problems that were calculator and I put some problems that aren't calculator, just to give you some practice. Okay, so we have to find area in between, right? Well, we just found out that to find area between two curves, we use this. Right? That's how we find area. That's how we find a region R. Capital R means area of R. Okay, so let's fill it out. First thing, let's start with the easy one. What's the top curve? So the top curve, so this is where a picture helps. This is where a picture helps. Because over here, this is the top. From negative infinity to like 0, this is the top. And from like, looks like 1 afterwards, this is the top. But what is the only piece of this graph that we care about? R. That's all I care about is R. It's not asking me about anything else other than R. So what I usually do is I shade them. So I'm going to shade the top curve and shade the bottom curve a different. So the pink is the top curve. The orange is the bottom curve. So let's go back to our question. One of them is F, one of them is G. And F won't always be the top. Sometimes G is the top, sometimes F is the top. So don't take that for granted. Just because it says, that's why it says this part here, right? That's why it says this only works if G is bigger or is smaller than F. If it's not, then then it doesn't apply. Okay, so let's go here. There are two parabolas. Which parabola is on top? Which parabola is going to be on top? F, which is x squared, or G, which is negative x squared plus 2x? How do we know it's G? How do I know that this is G and this is F? How do I know?
Parabolas that, how do I say this, that have an upside down U shape usually have a negative in front of the function, but parabolas with the regular U shape don't have a negative.
Exactly. Parabolas have two shapes. That or that, right? Arrows up or arrows down, right? Both arrows are usually up or both arrows are usually down. It could be skinny, wide, but that's usually what they look like, right? If it has a negative A, that's what it's going to look like. If it has a positive A, that's what it's going to look like, you know. So G has a negative A. This guy right here is a arrows down parabola. So G is on top, F is on bottom. Okay? G is negative x squared plus 2x minus f x squared dx. Okay? Now we got to do the bounds. Bounds over here were from A to B. When do we know where the bounds are? Where do we look at a graph? It's where the shade starts and the shade ends, right? So let's go down here. Where does the shade start and where does the shade end? Mhm.
Starts at 0, ends at 1.
So starts at 0, ends at 1. How do we know those are correct? How do we know it's not 0.001 and 1.1, 0.9999? How do we know that those are exactly 0 and 1? So we can plug it into the equation, or what else? Let's see if we remember from last lesson. Well, how else can we show that those are 0 and 1? How can we show that those 2 points that bound the green stuff in, all right, the bound the green stuff in? So these 2 points, let me make dots here. This green dot and this green dot, or sorry, red dots, those 2 red dots. How do we know that that's at 0 and 1? Mm-hmm. The what?
The parabolas.
What about the parabolas? Okay, so how can we show that those are 0 and 1?
Those are the points where they intersect, so we can find.
So they intersect, right? That's where that's where F and G intersect, right? We talked about this. How can we find if they intersect? Wherever they intersect is where they're equal to each other. So let's solve them. Let's set them equal to each other. We can't use a calculator, so I can't graph them. Okay? So what I'm going to do is I'm going to set them equal to each other. Solve for x. Just solving a quadratic. Something you guys have been doing since math 2. Solving a quadratic, and we get they're equal when x equals 0 and x equals 1. We've proven that that's where the 2 dots are. Don't take for granted that, oh, that's 0, that looks like 0 and that looks like 1, because no one said the graph is to scale. So don't ever take that for granted. Okay? Always check. Always check. And if they don't let you use a calculator, there's always a way to check by hand. Okay? All right. So now we can solve this. All right, well, this is plus a negative, so I'm going to combine before I do negative 2x squared plus 2x dx. What's the area under the curve? Don't look up here. You guys did questions on tests way 10 times harder than this. You guys know how to do this. It's a good practice. area under the curve is 1/3. Area under the curve of area of R, I should say, R is equal to 1/3. Okay. So the hard part about this is getting the bounds. If you don't have the bounds, getting the bounds, that's the hard part. And that's pretty much it. That's pretty much it. Because after we got the bounds, this question here, I mean, this question was about 4 times easier than anything you had on the integration test. The stuff on the integration test was way harder than this. They're not going to, and then, so for non-calculator questions, they're pretty tame doing it by hand. When they start getting a little crazy, that's when you use a calculator. Okay? Like on number 2, like on example number 2. Number 2 is in a calculator question, or yep, number 2. It says use a calculator. So anytime it says use a calculator in this class, you're probably going to need one. Probably going to need a graphing calculator. They don't let you use calculators just to add 2 fractions together that are really hard. They usually, when they want you to use a calculator, you're going to have to use some of the graphing calculator functions. Okay? All right, so R. Let R be the region bounded by f of x and g of x, as shown in the diagram below. Find the area for R. We can use a calculator, and we got a round. Okay, so here's R. Looks like it's being bounded at this red dot and this red dot. That's where the areas are being bounded. What do I mean by that? That's where they're closed off. That's the beginning of the green and the end of the green. Okay, and then you have 2 functions. This one is the top. This one is the bottom. So what we have to figure out is which one is f and which one is g. So is the pink f or is the pink g? Well, this one's not as bad. F is a quadratic. G is linear. One of them's a parabola and one of them's a straight line. So this one's pretty easy to tell. Oops, I don't want to use that color. F is this guy. G is this guy. Okay, so let's set it up. R equals, we still don't have the bounds, but I know what the top is. The top's going to be f. Negative 3x squared plus 5 minus g, which is negative 4x dx. I can use my calculator, which is nice, but I need bounds first. Calculator won't do integration, it won't do area under the curve unless you give it bounds. So let's go back to our picture. I have to find the x coordinate for those red dots. This red dot and that red dot. So I have to use the calculator for this. Okay? So let's go to the calculator. See if you can do it on your own. Try to do it without looking up here. Remember, for negatives, put the negative sign. Don't put the minus sign. It'll give you an error if you try to put a minus instead of a negative, even though they're the same thing. The calculator doesn't like it. Zoom decimal. Okay, there's the graph there. Now I can see where it intersects the top on the left side of on the negative x side, but I can't see where it intersects on the other side, so I'm going to zoom out a little bit. Zoom out. Right there. Okay. Now I need to find intersection. I need to find intersection of the red and the blue. There's two spots where it intersects. I need to find both of them. So second trace, which is calculate. I want to calculate intersection. Where's the first curve? Where's the second curve? And then where's your best guess as to where they? So the first one on the negative x side is going to be, looks like negative 0.7863. That's going to be the lower bound. Negative 0.7863. Okay, so now let me find the one on the other side. So I'm going to do the same thing. Second trace, intersect, first curve, second curve, best guess. And there it is, 2.1196. 2.1196. I'll stop right there. You can put 3 on there, but since I did 4 spaces for the last one, I'll do 4 spaces for this one. 2.1196. Okay. Not done with the calculator yet, because now I'm going to ask the calculator to actually solve this thing. Before you ask the calculator to solve it, it's probably best to clean it up a little bit. You want to make it as simple as possible as the calculator, because sometimes the calculator will act funny sometimes. So these guys are negative, negative. So the function is negative 3x squared plus 4x plus 5 dx. That's the guy I'm going to ask the calculator to solve. So I go to math, number 9. Oops, nope, not there. Home screen math. Negative 0.7863. Positive 2.1196. Then the function is negative 3x squared plus 4x plus 5 dx. And we're going to round to the nearest thousandth. So thousandth is 3 places. 3 places past the decimal. So 12.269. 12.269. So the area is approximately 12.269. Done. Okay. All right. That's about as hard as they get. That's about as hard as they get for area between curves. Area between curves is pretty cut and dry. It's not really hard, is when they don't give you a picture. When they don't give you a picture, like the next one, they won't give you a picture. So we have to draw the picture. Okay? So we have to draw this picture. And it doesn't say anything about a calculator. So we can't use calculator either. Okay, so let's look at number 3. Okay, it says find the area of the region bounded. So in between the functions f and g. So f of x is e to the x. G of x is x. The vertical lines 1, x equals 1 and x, so in between those. All right, so let's draw a picture. First thing we're going to do is draw a sketch. It's not going to be perfect, but at least it'll give us a visual of what the heck we're doing. Okay. The first one is g of x. G of x is easy. It's just, it's a straight line. So when x is 1, g is 1. E to the x, e to the x. All right, so I need to plug some points in for e to the x. E to the x. Okay. So, or let me put these vertical lines first. Let me put these vertical lines. Vertical lines at x equals 0. So x equals 0 is going to be the y-axis. X equals 1 is going to be this line here. Okay, e to the x. This is a very tight space, so I don't have to get a lot of points. But one of the points I have to get for e, 0. When I plug in 0 for f of x, what do I get? 1. Okay. Actually, you know what? Let me use a different color. So all of these are kind of blended in. When I plug in 1 to f of x, what do I get? E. Yeah, just e, which is around 2.78. Right, which is around 2.78. So let me move my graph a little further down. Right around there. And e is exponential. So e is gonna, it's not gonna be a straight line, it's gonna be a curve. Okay. So now the area bounded by all 4, by f of x, by g of x, by x equals 0, and x equals 1. Where is that area going to be? Well, you have a couple bounded areas. This area is bounded right here. Problem is, it's only bounded by 3 of them. It's not bounded by e. So that area is not the one we're looking for. That area is not the one we're looking for. The other bounded area is this guy here. That guy is bounded by e to the x on top, x on the bottom, 1 and 2. So that's the area we're looking for. That's the guy we're looking for right here. So you know what? Let me keep it the same way, green. And call this R. Okay. That's the area there. Without having drawn that picture, it's very hard to see. It's very hard to see which one's going to be on top, which one's going to be on bottom. It's just very hard to see. So that's why drawing a picture will help. Okay, so let's set it up. R equals top curve minus bottom curve. A to B. Okay. So which one is going to be top curve for the green? Which one is going to be top curve for the green? F or G? F. E to the x is on top of the green stuff. It's on top of the green stuff. It's keeping the green stuff in. Without e to the x, the green stuff would just go up to the sky. It's bounding it in. And then the one on the bottom is x. So the top curve is e to the x, minus the bottom curve, which is just x dx. Right? What are the bounds? Mm-hmm.
0 and 1.
Yeah, how do I know that? How do I know it's 0 and 1? You're right, absolutely right. It's going to be 0 to 1. How do I know that? The answer is easier than you think.
It's already in the problem.
They told us, yeah. Mm-hmm. They told us the bounds. They didn't word it that way, but they told us the bounds. We don't even have to check. I don't have to do any set it equal. I don't have to do what I did for number 1. They didn't tell me anything about the bounds in the question, so I had to figure those out. Same thing with number 2. But number 3, they actually did tell me the bounds, right? Those vertical lines, 0 and 1. Okay, so here we can't use calculator. We're not allowed to use calculator, so let's solve it by hand. Again, you've done stuff way harder than this. This is not anything you can't handle. So, antiderivative. What's the antiderivative of e to the x? E to the x, yep. Minus, derivative is 1/2 x squared. And I have to evaluate from 0 to 1. So I'm going to plug in 1 for x, and then I'm going to plug in 0 for x. Let's see what I get. Okay, so over here I get e to the first minus 1. Oh, sorry, minus 1/2. Minus 1/2. Okay. Over here, e to the 0 is 1. And then this guy over here just becomes 0 because it's 0. So it's really e minus 1/2 minus 1, which is e minus 3/2. And you were done. That's R. That's area under the curve. Okay. That's the only time when it. So when you don't get a picture, draw a picture. When you don't get a picture, draw a picture. Okay. This one is calculator. We can use our calculator for this one. And they don't give us a picture. So we're going to use our calculator to give us a picture. Okay? So the first thing, I don't want to plug in points. I don't know where the bounds are. I don't know anything about it. So let's just go right to the calculator. Let's get a picture in our head using the calculator. Okay, so the f of x is x divided by square root x squared plus 1. The next one is a 4th power. So we go x to the 4th power plus or minus x. So let's see if the calculator read exactly what we wanted it to. It's not that bad. Zoom, decimal. Hopefully it doesn't give us an error. Nope. So we're good. So there's one function and there's the other function. Okay. So the area bounded. So you really don't, you don't have to draw a sketch. It's not required to draw a sketch. I just always like to refer to a picture. Well, there's a picture right there, right? So you don't have to draw that picture on your paper. You can if you want, but it's not required. It's not required. But most of the time, like I said, most of the time with students, when I help students on this, it's because they can't visualize it. It's hard for them to see. Because once you can see this area, you're like, oh, okay, I know where the left bound's going to be. I know where the right bound. I know where the area is going to be. That area there. Okay, that's what we're looking for here. This guy right here. Okay. So on our paper, we need to jot down some things. I need to jot down some things. I know the formula. Top curve. Which one is going to be the top curve? Because this is what I need to see on your paper. Which one is going to be the top curve? The blue one. Okay, but which one is the blue one? F or G? F of x. F of x, the square root one. The square root one is the one that kind of looks like an S, the blue one. The one that looks like an S, that is the other one. Anything to the fourth power kind of looks like a W parabola kind of thing, so that's the red one. So on your paper, you don't even need to put the whole f of x. You can just put, since it's labeled as f, you can put f minus g. That's acceptable. Because it said use your calculator. So we're not having to calculate anything by hand. We're just showing how we got our answer. Okay? So next thing is the bounds. Let's go ask the calculator. Looks like one of them is 0, but I'm not going to take that for granted that it's exactly 0. So I'm going to say first curve, second curve, best guess. It is 0. Okay. So the lower bound is going to be 0. And then let's do the next one. Second calc, intersect again. First curve, second curve, best guess. So I got to scroll to the best guess. You want to get as close as you can to the best guess. Does it have to be perfect? No, but just you want to get as close as you can. And 1.1808. 1.1808. Okay. Those are the two bounds. Now I have enough information to solve it. I'm going to ask the calculator to solve it now. Okay. So let's go back to here. So remember, F is my top. G is my bottom, Y2. So I'm going to use a little trick. So because when you do this, when you go to math, when you do this, you have to type in the whole thing. And this is where some mistakes can happen, because if you don't put parentheses in the right spot, or the you use a negative instead of a subtraction, it gets a little dicey. So this is what I'm going to put the bounds in: 0, 1.1808. And then I'm going to use my little trick, right? F is Y1. F is Y1. That's the one I want to go first. So my little trick is vars, V, right underneath it, under, Y bars, give me all the functions, I want Y1. Minus vars, y vars function y2. You don't have to do it this way. You can, but if you're not going to do it this way, you have to plug in the whole thing. What f of x is, what y of x, just like you did to graph them. But this is a little bit easier. It takes less room for error. Hit enter, and there you go. Since we're rounding this, we're going to say approximately. So the area under the curve is approximately 7.7854. Less than 1 unit. Not a very big space. Okay. So on paper, it doesn't look like we did a lot. But there's enough. I know exactly what you did. I know exactly how you got that number. You never, ever, 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 ever want to answer a question and then have the person grading it say, how'd they get that answer? Right? If you show this, okay, I know exactly how they got that answer. They used the calculator and they inputted it, and that's correct. F minus G, that's correct. Okay, so it's not a lot of work, but it is important. Okay. All right, so I want you to do, last one we're going to do. Last one, let's see. This is not a calculator question, but use the calculator. I want you to use the calculator since we're running low on time. It's not a calculator question, but use the calculator to do this. Number 5.